the thing you need to double check is make sure that you have like a credit card attached to it. So Google isn't actually going to charge you anything, but they need to have like a credit card attached to the account. So the way that Google Cloud works is you get like, I think $300 of free credit when you first sign up for it, and you give it your credit card in order to do that. If you accidentally like end up using more than that, Google will actually like stop your services from running until you like explicitly tell Google, I want to actually start using my credit card now. So it's not going to like, you're not going to like silently run out of $300 and then it'll start like charging you. You'll have the opportunity to like opt out of that if you want. Okay. All right. So if you haven't signed up for a Google Cloud account, what I would recommend is following. Well, actually, you know what? Maybe the first thing that I should do is I'm just going to share this entire presentation on the Slack channel, because there are going to be some things in it that are like instructions, step-by-step kinds of stuff. And I think for some of you, it may be easier to just copy and paste and kind of follow along asynchronously. And I apologize ahead of time if this is a horrible presentation, because I put it together like 30 minutes ago. All of these instructions are sort of changing very rapidly, as both like the technology side from the Jupyter end changes, and as also we figure out sort of different ways to use these computational resources that are out there. A lot of what Jupyterhub and these instructions are basically one path through like a potential of like many thousands of paths you could take in terms of setting up these different sorts of computational resources and stuff like that. So what we've done is we've taken some time to try and find like a few steps that are sort of more consistently going to work for you and that are relatively easy to figure out and follow. And so what we've done over the last couple of months is put together a set of guides that are that you can follow to get yourself set up with this stuff. Okay, so there's the Google Drive link right there. You can click on it in the Slack chat room. And if you want to just follow along with that, then that's fine too. Okay, now I have lots of anonymous squirrels and badgers joining. All right. What's that?
The other Chris. Make sure you get the squirrel.
Yeah, really they should all be squirrels of varying types, I guess. But we're not that advanced yet. Okay, let's see. What is the right way to do this? So for those of you who haven't yet, there's a section in here that tells you how to sign up for a free Google trial. Some of these steps are things that will take a few moments to occur. So for example, when you sign up for a free trial with Google, it triggers some machinery on Google Cloud that may take like a few minutes at least to happen. So in general, try to like follow these steps as much as you can, and then I'll try to like insert periods where I'm talking so that we're all not just like waiting here in awkward silence. But in particular, follow this, like sign up and give it a credit card if you're interested in doing that. And then I'll start off going through here, like enabling these services, but it'll probably be easier for you if you just start doing that ahead of time while I'm talking. It's just FYI. And what I'll do is, here and there we'll kind of stop and like make sure that people who are interested in like remaining caught up have time to debug things and stuff. There is every possibility that something will go wrong, like catastrophically so, and it won't work. And in that case, what I'll do is just sort of try to cover some of the like high-level ideas of the point behind Jupyterhub, and then we can try to debug offline or something like that if you want to. Okay, so this is a set of material that is very loosely based off of a guide that we put together called Zero to Jupyterhub. And I'm going to refer to that guide a number of times here. But the short version is that Zero to Jupyterhub is meant to be like a very quick and easy way to go from zero to having a working Jupyterhub installation. You can access all of that at this website right here, z2jh.jupyter.org. And it's effectively just documentation, similar to what you would see for a project. But it's got a deployment guide right here. It'll tell you how to do things like create a Kubernetes cluster on a bunch of different cloud providers. It'll teach you how to set up Helm, which is one of the tools that we use to deploy Jupyterhub. And then at the bottom, this is stuff that I'm not really going to go into here. There's a bunch of stuff on extending and configuring your Jupyterhub. So that's things like saying how much memory you want users to have, or using like a custom Docker image that you serve to people. And I can go over like, a couple of these things in there after the initial demo. But if you have more questions about that sort of stuff, feel free to just ask me questions, and we can try to figure it out that way. Okay, delete. Go back here. All right, so the main reason that we have been developing Jupyterhub at Berkeley, and this has been sort of like a partnership in some sense between some of the education-minded people at Berkeley and the Jupyter team. There have certainly been lots of other people working on this in different parts of the world, but this has been one of the sort of like core driving engines of the project. There are basically two main use cases that I can think of for this right now. The first one is from a pedagogical standpoint. If any of you have ever taught a boot camp or a class or a workshop, you know that like getting the computational environment set up on everybody's computer is a huge pain in the butt. It really sucks, and it wastes a lot of time, and it frustrates people. Sometimes it's just impossible to do. Sometimes you have to tell someone like, oh, you're running Windows, sorry, like you just can't follow these materials, which is in some sense it's a really unsatisfying thing, and I think it has actually like a lot of implications for things like, oh, I should not have the chat window open here. I think it has a lot of implications for things like accessibility for people who can't afford fancy computers and stuff like that. So there are a lot of good reasons for why having control over the computational environment is a benefit to you as an instructor. The second reason that people have thought about deploying these things is basically to allow you to connect users to more fancy computational hardware or data or something that exists on another computer that they wouldn't be able to have on their own computer. So whether that means like, I want to be able to run code on a cluster that has a bunch of GPUs, or I want to be able to access a gigantic data set that would be way too hard to ship to each individual person or to store on a thumb drive or something like that. You can also use Jupyterhub as sort of an entry point into some other like computational architecture that might be out there. So for example, we're using a Jupyterhub in this class in order to have access to all of these like high memory machines with a custom environment installed with lots of different software and complicated machinery in there. So the sort of one sentence description of the goal of Jupyterhub is to flexibly connect users to those computational resources that you specify. Those can be in the cloud, they can be in like an institutionally run cluster, they can be on like a computer sitting over in the corner of the room that people have like internet access to. But the point is creating like a sort of user-friendly and familiar interface towards other kinds of computational resources that are there. And I think that at least the way that I approach it, one of the benefits of this is that there's this huge barrier to doing things in the cloud, for example, because the experience of interacting with the cloud is very different from the experience of interacting with your computer, right? Like you have to SSH into a machine, and now you're on the command line. You have to use a different set of tools that, oh, somebody's calling me. You have to use a different set of tools that aren't familiar in terms of like a user interface. One of the benefits of Jupyter is that it sort of lives natively in a browser. And what that means is that it may be possible to basically replicate the same experience regardless of whether you're working locally on your computer or whether you're working remotely on a cluster or in the cloud somewhere. And some of you actually experienced that during this week. I think a few people asked questions like, when I'm running this code on the Jupyterhub, am I running it on my own computer or am I running it somewhere else? That line is starting to sort of get blurred. And while that provides some challenges, challenge is it has a huge benefit that you're sort of lowering the energy barrier towards utilizing these sorts of online computational materials. Okay, so what we're going to do for the rest of this is basically go from nothing to having like a very minimal Jupyterhub setup. We could go for hours and hours and hours trying to figure out how to customize it to exactly the kind of thing that we want. And Ariel certainly has done that for this Neurohackweek bootcamp. But I'm not going to go into that much detail for that sort of stuff. Again, as I said, like a lot of this material is coming from this Zero to Jupyterhub guide that we put together. So refer to that in the future if you have questions and if you want to learn more about how to do this stuff. So I'm going to talk a little bit about the kind of high-level concepts that we're going to be dealing with here, maybe give some explanations for some of the tools that this particular version of Jupyterhub is using. We'll hopefully be able to get some sort of a running Jupyterhub on most of the people's computers. And again, by computers, I mean on your like Google Cloud instance that's running in the cloud. And then at the end, we're going to tear everything down so that we don't give Google a bunch of free money, basically. So this is a very high level, I don't know, there we go. Do you know how I can turn it into presentation mode without being full screen?
Presentation mode per definition is zero.
Yeah, I'm not sure you can.
Do I have access to the... All right, whatever. So this is a very high-level view of sort of the different components that are at play in something like a Jupyterhub. So, for example, let me draw that down so that you can see better. So what users experience is mostly like up here on the top, right? These are each individual, what are called user pods. And you can kind of think of these as like almost little mini computers. So there's one for each user. It has its own computational image that is specified, usually with like a Docker image. It has its own little collection of resources like memory limits and CPU limits. It may be connected to other kinds of things like data sets that live elsewhere, whatever. But basically each person kind of owns their own pod here. So on top of these things are Jupyter hubs. Jupyter hubs are basically able to like flexibly create and destroy these things on demand. And Jupyter hubs are trying to run all of this stuff on actual hardware, right? So the hardware is down here. This could be like any kind of cloud infrastructure hardware, AWS, Google Cloud, Microsoft Azure, whatever you want. Somewhere there are machines that are actually running this. And so then the question is, like, how can you be smart about managing all of this stuff going on up here so that all of this stuff down here doesn't get like overloaded or break? And for that, there's a layer of Kubernetes in between those two things. And I'll explain a little bit more what Kubernetes is later on, but the short version is that Kubernetes kind of manages this relationship between the green stuff here and the black stuff down here, in some sense. There's certainly lots of different ways that you could do that mediation between the green and the black, but Kubernetes is one that we've found that works really well for our purposes. Okay, so as I mentioned, today we're going to set this stuff up with a focus on Google Cloud, but you could totally do this on any of the other major cloud infrastructure systems. The only caveat is that you need to be able to run Kubernetes on that whatever cloud system that is. So on AWS, we spent some time to figure out how to get Kubernetes set up on it. Once it was there, like Jupyterhub was pretty easy. Same thing goes for Azure, same thing goes for your own laptop if you wanted to. Kubernetes is kind of like the core part of this deployment for Jupyterhub. So we're going to start off by sort of focusing on creating this hardware in the first place, because while these computers exist out there somewhere in a server farm, we don't have as users access to them. So the first thing that we need to do is tell Google, okay, like I want you to give me a couple of machines that I can start to run stuff on. So if you haven't done this already, go to console.cloud.google.com, and I am just going to type it in. So console.cloud.google.com. And this is the sort of main entry point to the Google Cloud Console, which has a lot of nifty features that we'll use later on. If you haven't signed up yet for an account, hit sign up for free trial, select individual. It'll ask you to fill in some information, give it your credit card information. You won't get charged, but they need that just for accounting purposes. And you'll have a bunch of free credits that you can use to run this stuff so that you won't actually have to spend any money.
You do this more than once?
I mean, you don't get a new 300 each time.
Used up my 300 a year ago or something.
Okay. Well, it'll be, so I mean, it's not very expensive. I think that like all of this will just be like a couple of bucks or something like that.
Amazon. Can I follow you on Amazon?
I mean, everything after the setting up Kubernetes part will be pretty much the same. Yeah. Yeah, so the first part of this won't apply, obviously. The only difference is that like setting up Kubernetes on Google Cloud is pretty much trivial, whereas doing so on Amazon is definitely not trivial. I think it will become easier over time. But another thing that you can do is that I would personally never do and have definitely never done is create another email address so that you can get another $300 on Google Cloud. I think that might work if you were an immoral person. That I would never do such a thing. But you could try that if you wanted to. Okay, so the first thing that we need to do, some of you may have already done this if you've used like Google Cloud stuff before. The first thing that we need to do is basically tell Google, like, it has all of these different tools for doing different kinds of cloud computing things. And by default, for some strange reason, like very few of them are actually enabled. So there are two pieces of the kind of Google puzzle that we need in order to run Kubernetes and thus run Jupyterhub. The way that we can enable these things is by we click the little hamburger menu on the top left, click on APIs and services, and then click on library. So, first I'm going to create a new project. You shouldn't have to do this. Unless you already have a Google Cloud account, you shouldn't have to do what I'm doing right now. But I'm creating a new project which kind of gives me like a clean slate on Google. We'll call it NHW 2017. And we'll switch to it. Okay, it's still being created. So what I want you to do is click on the hamburger menu, go down to APIs and services, and hit library. So what this does is it gives you a list of all the different API components that are available to you through Google Cloud. And so these do all kinds of different things. We don't care about most of them. But the two things that we do care about are listed right here. So one is search for Compute Engine API. So Compute Engine API. And it'll narrow down our list. And that's what we want right there. So if you click on that, and then click on, in your case, it should say enable, that button right there. Then it'll start creating that API tool for you on your Google Cloud account. The next thing that we need is the Container Engine API. And so we just go back here, Container Engine, there it is. Click it and click on enable. Let's see if my project is done spinning up. Yeah, okay. Library. So this is now the new project that I just created. We'll do Compute Engine API. Click on enable. Go to library. Container Engine API. Click on enable. And this usually takes like a couple of minutes, maybe like 2 or 3 minutes or so. So when you do this, Google is like going back into its vast jungle of APIs and tools that it has, and it's connecting those things with your account. So basically, any of the stuff that you do on the cloud in these situations, it takes a moment of time because there's actually quite a lot of machinery that's happening under the hood that we're not really exposed to as users. Okay, so a really nifty thing about Google Cloud Computing is that they actually give you a little in-browser terminal that you can use that's sort of already connected with the hardware that's up there. You don't have to use this, although for this tutorial it's what I'm going to be using. If you wanted to use like your own terminal on your computer, then you basically need to install an SDK that connects with Google Cloud so that you can send commands to it. But we're not going to worry about that here.
Have you commissioned the machine yet, or this is still all independent?
Still all totally independent. Yeah, we're just kind of like setting the groundwork that we'll use. Yeah.
Just to make sure that I'm getting this straight. So for all of this that we're doing, we're going to create a Jupyterhub, right? Mm-hmm. But when we say I write like some code and I put it in a container, etc., and I want to give it to someone, they don't need to do all this in order to do my stuff, right?
No.
Okay.
Yeah. I mean, if you've already got a Jupyterhub set up, then from a user's perspective, it's the same thing that everyone here has been doing to use the Jupyterhub here. You just go to a URL and you just get it. Yeah. So this is something that you like, you know, it's all front loaded on the developer or on the on like the instructor side, and once you go through it like once or twice, it actually becomes much easier. It's all of these tools are usually very unfamiliar the first time you use them, but you kind of get the hang of it after a while. I mean, that's certainly what happened to me. So.
Follow-up question.
Yeah.
So the money that we are getting for free, but like later we would have to pay or get from somewhere to pay Google. When someone else comes and uses my code on their data, they'll be draining from that same pot of money, right?
Yep. Yeah. I mean, the way that Jupyterhub works right now, and what we'll do in a second, is you basically create you reserve the computers at a first step before you ever set up Jupyterhub or anything like that. And as soon as you do that, now you're paying Google for that time, right? So whether those computers get used or not, you're still paying Google for, you know, the right to have like, you know, 5 instances of this particular machine type or whatever. So if users are using those or not, you're still going to pay Google.
Is there a flexible way?
There is. I'm not going to cover it here, but thus far I don't think we've found out a good way to just make it like a general auto-scaling kind of thing. Because what you would want is when a bunch of users log in, it sort of scales up the resources, and when they log out over time, it like slowly brings it back down. You can definitely do that, but that's something that will usually depend on what cloud provider you're using and how they handle that kind of thing. And obviously there are like 1,000,001 algorithms for doing the auto scaling itself based on the usage that you expect. I guess, well, I'll get to this aside in a second because I want to run a command that'll take a bit of time to finish up. So we can access that console by just clicking this little guy up here. And so now what Google is doing is it is provisioning a shell that lives in the browser that is sort of already connected to all of the resources that Google has for cloud stuff. And these are old ones, so I'm just gonna, you can click the plus button and it'll create new shell tabs. And since this project is the one that's active for me, it should say, yeah, NHW 2017. So now I have a shell within this NHW 2017 project, and I can run stuff under this project with Google.
And that's some general computer, some shell is sitting on some Google computer,
Yep.
so not your computer yet.
Exactly, yeah. Okay, so now what we're going to do is actually create those, we're going to ask Google for those computational resources. And this is not necessarily copy-pastable because of how Google Docs handles like spaces and stuff like that. But if you just take this and turn it all into one line, you should be able to just copy and paste it into Google Cloud. So I'm going to do that right now. I've already got it written here. And then I will explain what exactly this thing is doing. Enter. Okay, cool. So what did we just tell Google to do? So this is the API that Google has for how you can ask things from the command line for different kinds of computers. So what we said is this is the entry point to like the Google Cloud API. Create a cluster, call it NHW 2017. The zone this is related to what the woman from a couple of days ago was talking about. The zone basically says like where in the world do we want these machines to live. Generally speaking, you want to pick something that's close to you geographically. So US Central 1B is just some server farm that exists, I think, in the center of the country. Cluster version is a way of telling Google Cloud what version of Kubernetes you want to run. So Kubernetes is software like anything else. It has new releases, and sometimes you want to pin your deployment to a particular release. Usually you just want the latest release of Kubernetes. Num nodes is just how many machines do you want. And then machine type is what kind of machine do you want. And so as an example of that, when you run that and hit enter, you should see creating cluster and whatever it is that you decided to call it. This will take a couple of moments. So as a quick explanation of machine type, and sort of as an answer to a question that you had brought up, in the Zero to Jupyterhub guide, we have a little section on trying to estimate the cost of your deployment here. And we put together a little kind of interactive cost estimator that's actually this is a binder link. And if anybody wants to talk about binder, I'm happy to talk about it in a different sort of situation. But basically, when you click on this link, it should fail. And so you just look at the fail message and then you go back to what you were doing before. Let me just show you the list. Actually, the only thing that I wanted to do was show you this Google Cloud Machine cost list. Let's see. Okay, so this is like just as a frame of reference here. These are the different kinds of machines that we can ask for, and each one of them has things like, you know, different numbers of CPUs attached to it, different amounts of memory attached to it. Some of them are optimized for CPU. Some of them are optimized for memory, and there are actually quite a lot of these things. Some of them are optimized for bursting, so like little small like shots of activity and then like long periods of inactivity. What I would recommend is to sort of like look through the documentation here based on what you want. For example, I think that for this Jupyterhub for Neurohackweek, Ariel, we're using like a high memory something. I mean, we're not using any of these because we're using AWS for Neurohackweek, but
It's very similar actually to this.
Yeah.
Something like your high memory 32.
Yeah.
These are actually much more. Like the high memory 16.
Yeah. So like all of these things will determine how many machines you actually need, right? And so you should choose these based off of like how many users you think you're going to be in your boot camp or in your class or whatever. What are the resources you think those people need? One thing that's probably worth mentioning is that generally speaking, your bottleneck is going to be RAM. And that's partially because RAM is something that if it gets overloaded, like everything breaks, basically. CPUs are, where am I pointing? I guess that, yeah. CPU is something that people compete for. And if there's a ton of people and they're overloading the CPU, it just means that everybody's stuff is going to go very, very slowly, but it's not going to like malfunction. So generally speaking, you want to have like a good buffer of RAM if you're going to have to pick something. And that's just kind of like a rule of thumb kind of a thing.
So it's not the case that you're specifying a machine per user, right?
Right.
These are, you're specifying some number or size of machine that
Yep.
then will be on.
Yep. Yeah. And I'll talk about that a little bit when we talk about Kubernetes next. But
You're going to kind of want to have a core per user type of thing. So if you knew you're going to have 32 users.
it depends. Yeah, it just depends on what you want them to do. Yeah. So you can in the customizing bit, which I can show, I guess, after this stuff. You can see how you can basically say like, I want each user to be guaranteed, 20% of a CPU or 50% of a CPU, or whatever. So you can standardize things in that way. But let me get to the Kubernetes stuff, and we'll talk about a little bit about this there too. Let's see how this guy's doing. Oh, okay, cool. It's already created. That's good. Okay, so really quickly, like, why is it that we've been talking so much about Kubernetes? As I said, you can deploy Jupyterhub, and we do this all the time using other kinds of like cloud management sort of solutions. But over the last couple of months, especially at Berkeley, like, we've come to really appreciate and value Kubernetes as like an open source option for doing this, which is why I tend to focus on Kubernetes when we talk about this. One of the reasons for this is that Kubernetes is really scalable. I mean, it's built for flexibility and scalability. It was initially a project that came out of Google in sort of figuring out their own server cloud application management challenge. They open sourced the code for Kubernetes. And so basically, if this is something that can handle the sorts of computational challenges that Google has, then that is orders of magnitude more complex than anything that like we're going to have to deal with, generally speaking. No offense to the deep learning people in the room. So probably these tools are going to be more than necessary. So there are two big pieces here. The first one is Kubernetes, and the second one is Helm. And I'm going to talk very briefly about each one of them. So this is something more for the sort of computer science-y, DevOps-y people in the room. But a phrase that group of people loves to use is that this is a good level of abstraction, which basically means that it's sort of the right level of balance between giving you like all the knobs in the world that you can turn to customize it exactly how you want, but also being relatively like simple to use and not requiring like constant human input in order to manage. So it lets you like pretty easily change the configuration of the hardware that you're using in the cloud. It lets you do things like scale it up and down relatively easily. It handles things like faults and breakages, and when things go wrong, it usually doesn't like mess everything up, which is really valuable. But also it has like a really nice open source community around it. So there are tons of people that don't work, at Google or even at the big tech companies that use Kubernetes. There are, message boards and Slack chat rooms and stuff like that where you can go and ask questions. And so that makes it a lot easier to use that, to sort of incorporate that software into your own workflow. It makes you less likely that you're just going to get stuck in a rut and you won't be able to get yourself out of it. The other thing that I want to mention is sort of like a subset of Kubernetes called Helm. And basically, what I mentioned before is that Kubernetes is just a system for being able to manage all of these computational resources in the cloud. And Helm is a way that you can tell Kubernetes what you actually want it to do. So think of Helm like the steering wheel that you can use to steer Kubernetes in one direction or another. One of the key concepts in the world of Helm is something called a Helm chart. And we're going to create one of these in a second. But basically, that's just how you tell Kubernetes, like, I want this number of computers. I want each user to have this much RAM or this much CPU. I want it to be like connected to these sorts of resources, that kind of thing. So you can use Helm charts to create Kubernetes deployments. And you can kind of think of Helm charts almost like apps in like an Apple App Store or something like that. So a Helm chart is just a particular set of instructions for creating like a set of materials the way that you would want them. If you go online, there are GitHub repositories that just are like collections of Helm charts, and they do things like, this is the Helm chart for deploying WordPress, and like this is the Helm chart for creating a chat room on your website or something like that. So you can just kind of pretty easily like plug and play with these kinds of things. And so what the Jupyter team has done is they have created a Helm chart for Kubernetes that deploys Jupyterhub. So that's what we're actually going to be using when we use Kubernetes. So the first thing that we need to do is actually install Helm on the cloud. And for that, you can just copy and paste this link right here. You just curl it from the internet and then install it in the cloud. And this step is only going to work after the cluster is finished creating, just FYI. So I'm just going to copy paste that here, hit enter, it goes online. It's grabbing that package from the internet, and then it should install it. Let's see. And it's already installed on here, so it doesn't really matter. And after you've done that, then you need to run Helm init. and this just initializes Helm on your instance and sort of sets things up so that you can start to use it in order to deploy Kubernetes.
I'm sorry, I keep getting confused. So this is still on Google's API for you, or is this now
Yep.
on your individual free machines?
This is still just on Google's thing, yeah. Basically, this is just a way that you can connect with those machines, but we haven't like SSH'd into them or anything like that. Yeah, this is just the particular like GUI way that Google lets you interact with this stuff. But we could just as easily be doing this on our own like laptops here with an SDK, just sending those instructions up into the cloud. Yeah.
So I think maybe to clarify relative to AWS, where you would always start up an instance to do any kind of interaction or use Amazon's SDK separately.
Yeah.
Here, that shell isn't a machine you're effectively paying for, I guess.
Correct. Yeah. The shell is something that Google provides for free, just to encourage more people to use Google Cloud.
It comes pre-configured with some things, but
Yeah, it makes it very, very easy that you can like install there's a function called kubectl, which is like the way that you control Kubernetes. That's like very easy to install on Google Cloud. It's non-trivial to install on like AWS. So Google kind of sets that up just to make it very easy for you to use those tools.
So you can't go wild computing or doing fun things in Google's world.
No. Yeah. It's very sandboxed. You have pretty narrow walls in there. So after you hit Helm init, you should see this phrase here, happy helming. There are a lot of like nerdy jokes in this world. For some reason, people are obsessed with nautical themes in this space. Like everything is like ship based, and like there's a helm of a steering wheel of it. I don't know why. Yes.
I had to figure out what it meant.
It does?
Yeah.
Kubernetes.
Yes, it does. Huh?
Yeah.
A cat.
Yes. Yeah. I definitely knew that. Okay, so the next thing that we're going to do is, add the Jupyterhub repo to this Helm deployment. And basically this is like adding a new package repository in pip or in Conda or something like that. It's adding a new channel so that it knows where to go and find this stuff. So again, I'm just going to copy and paste what I've already got here. And this is, if you notice, this is on the Jupyterhub website. So this is something that we've put up on GitHub, which is just the Helm chart to deploy Jupyterhub. And I'm going to type that in, Helm repo add Jupyterhub. There's the URL. Hit enter. It says, okay, we've added it to our repositories. Now, if you run Helm repo update, this is now going to go to that repository and grab whatever it finds inside the Helm chart and plunk it down on this machine here. So Helm repo update. Actually, Helm repo update. Okay, so it grabbed it. Now we should get a little thing here that says happy helming, this time with 2 ship steering wheels on either side of it. And if you're curious, I can show you guys what this looks like. I think this will work. Let's see. Okay. Let's go to Jupyterhub. So under the Jupyterhub org, I believe there's just a repo called Helm chart. And these are the instructions that we're sending to Kubernetes here. So basically, it's like a bunch of YAML that tells Kubernetes what to do. So chart.yaml right here. This contains configuration, like metadata, stuff like that, and then we can kind of compose. There are a few other YAML files in here that we use to actually tell it what kind of stuff to set up. I'm not going to go into any of that detail, but just suffice it to say these are what Helm charts look like. Okay, so we've got Jupyterhub sort of ready to go on this machine. Now what we need to do, the only thing that you need to manually do is create 2 SSL keys. And basically, this is just how your Jupyterhub can validate things. So it sends these tokens along in order to make sure that like things are relatively secure in what it's doing. So you can either in the Google terminal or just on your own computer, if you run this command, openSSL rand hex32, you run it 2 times. And then what we're going to do is inside of our Google terminal, we're going to create a file called config.yaml. I'm just going to use nano here to do that. And then inside, we're going to type the following. Hub : 4 spaces, cookie secret : and then copy and paste the SSL key you generated inside of quotes. So hub : 1234 cookie secret : apostrophes or quotes. There's the first one. And now I'm going to copy and paste the second one. And now proxy : secret token : proxy : 1234 secret token : and then the second one. So now we've given the 2 tokens that Jupyterhub is going to use. Basically, there are 2 different machines that we've created that we're going to create with this Helm chart. One is the hub and one is the proxy, and this allows them to talk to each other. They do different kinds of things in order to sort of create the final Jupyterhub experience. So then just hit Control-X. It'll ask you if you want to save it. Hit Y and enter. And so now we have a little Helm chart, a little mini Helm chart called config.yaml. Okay, so now we're actually going to install Jupyterhub on this cloud instance. So what we want to do is run, this is how you actually install an application with Helm. You run Helm install. This is something that Helm will be able to find now since we've added that repository to it. This tells us which version of Jupyterhub we want to use. I think this is the version of Jupyterhub. It's the version of something anyway. We can call these 2 things basically whatever we want to. This is how we'll refer to our Jupyterhub when we use Kubernetes to control it and things like that. I usually just use the same 2 names for each one of these things, and just call it something descriptive that you will remember, but that's relatively short because you may be typing it a lot when you're managing your Jupyterhub. And then we're going to point it to our config.yaml file here. And so basically what Jupyterhub is going to do is it has its own configuration Helm chart, the one that I just showed you that's on GitHub. It's going to look inside the folder you run this command from. It's going to find this config.yaml file that you pointed it to, and it will override any of the default Helm parameters with whatever parameters you put in here. And so that's how you can do things like change the default memory that's available to users and stuff like that. Okay, so I'm going to go back here because I've got it copy pasted. Oops. I'm just going to copy that. And so now we're going to install Jupyterhub. So I hit enter. And usually this takes a few moments because now it's going online to that repository. It's finding the Helm chart that's there. It's pulling it in, sending the commands to Helm to actually start creating the different bits and pieces of this machinery that is going to result in our functioning, hopefully, Jupyterhub deployment. Cool. Okay, so now it's done installing. This is a little Jupyterhub message that we wrote. And there are 2 useful commands that you'll probably want to know about. The first thing that I should mention is that, I think it's up here. So the way that what we've done now is we've told Kubernetes to set up a certain set of machines that are actually running a Jupyterhub. The way that we can control and get information about all of the machines that are running on Kubernetes is with this command right here, which people often call kubectl. So we say, okay, Kubernetes, inside this namespace, and this is why it's important that you remembered what the namespace was, because the idea is that you may have like multiple Kubernetes deployments running at the same time. This is how we tell it which one to go to. We say, okay, Kubernetes, within this namespace, do something with something. That's like usually the sort of pattern that you'll follow. It kind of follows like a verb object model. So we can say for the NHW 2017 namespace, get the deployment, and then it'll give us information about the deployment that we've just created. Another thing that's quite common is to run this command. Kubectl namespace equals NHW 2017 get pod. And this will give us all of the pods that are running on our Kubernetes cluster. So what you'll notice is that there are two things. There's a hub and there's a proxy. And these are just two different computers that in coordination do all of the stuff that creates Jupyterhub, basically. The other thing that we want now is, so as I said, this is now a running Jupyterhub that's on the cluster. So then the question is, how do we access that Jupyterhub? So to get that information, we run kubectl namespace equals NHW 2017 get SVC. And SVC is just a different kind of object in this Kubernetes world. Hit enter. And one of these is a public proxy. And what you want to do is look for that external IP address. And this is how people can access your Jupyterhub. So just copy that. And you can open a new window. And hopefully this works. There's a Jupyterhub. So this is running online on Google Cloud. It's providing by default what's called a dummy authenticator, which means that I can just type whatever I want in here and any password here. And so what it's going to do is when I type that in, it says, hey, do I have another user in here called whatever I want? And it doesn't, because there are no users in there right now. So now it's creating a bit of registry information for that user. I do not want to save that. And now I have a user account on this Jupyterhub. If I hit start my server, now it's sending that information to the Jupyterhub saying, hey, this person needs a user pod so that they can start running things on there. And now I have access to Jupyter within this cloud. So by default, it installs Python 3, but there's nothing else installed with it. So import NumPy, no module named NumPy, right? And that's, you can start to customize the packages that are available to people by creating your own Docker images and basically saying, I want you to feed this Docker image through the Jupyterhub to users. And so that's, for example, what Ariel did in setting all of that stuff up for Neurohackweek, was creating a Docker file that installs MATLAB and Python and R and sets all the data up and all that stuff, spins that into a Docker image that's registered online. And then in the config YAML, on the config.yaml file, there's a way of saying, I want you to give this image to people.
And I should mention, just to connect things to Satra's presentation yesterday, the NeuroDocker was the thing that created that Docker. You can do it pretty straightforwardly. Fairly complex dependencies, neuroscience dependencies with Docker.
Yeah. How to actually create that Docker image is like a whole other conversation that we can have that's sort of orthogonal to like Jupyterhub specifically. There's sort of a dark art to creating Docker images. One thing that we could do is retype that get pod command. So kubectl namespace equals NHW17 get pod. And what we'll notice is that now there's a new pod that exists. So when I signed in, Kubernetes created another user pod. It names it Jupyter- and then whatever username that you gave to it. And so using that, you can basically get an idea for like how many pods are created on your cluster. If a bunch of people are logging in, you can usually see that happening. So I'm kind of curious actually if, yeah. So this is the Neurohackweek namespace that we created for this event here. And probably nobody is going to be on this because we're not asking anyone to be. But these are the currently running pods on the Neurohackweek Jupyterhub. So Satra, being the diligent worker that he is going strong with this pod right there. And this is how, like, when people are logging in, we try to figure out if like everything is breaking, because you'll see a status message right here that says, one of a few different kinds of errors. If you wanted to like figure out what the heck was going on, if something was erroring, you can do kubectl namespace equals NW, what is it? NHW describe pod and then give it like Sutra's pod, for example. And it'll just dump out a bunch of information about that pod. I'm not going to go into like detail about how exactly to do all of that debugging, but I'm just giving you sort of like little hints for how you would go about learning how to do this in the future. Okay, so that's pretty much it. We now have a functioning Jupyterhub that exists with a public IP address. You know, we could link that IP address to a website if we wanted to. We could extend that Jupyterhub so that we could give it more memory and stuff like that. The place to go to learn about that stuff, other than just asking me, which I'm more than happy to chat with you about, is this Zero to Jupyterhub guide. So for example, if you go to this section, customizing the user experience, it has information about how to specify a Docker image. So if you add this to your config.yaml file, it's going to use this Docker image here. If you add, let's see.
Can you go back up to that? For example, if you wanted to rerun the environment that we had for this workshop, you would write Sutra/NHW17,
Yeah.
and the tag is 0.5.
Right.
There, and you would have the same environment that we had for the
Which we can send out on the Slack channel to if you're curious. Although from like a computational resources standpoint, that might be tricky. Because
running that one.
yeah,
Yes.
yeah. For example, if you wanted to increase the memory available to people, this is how you would do so. Limit means this is like the maximum amounts of memory that I want people to be able to have. Guarantee means that your users will always have at least this much memory, so they could always take up more memory if they wanted to, if it was available. And I would just read through this if you want to get a better idea of like how you could customize all of those things. So we don't have time to really go into a lot of detail on this stuff. The last thing that I want to do for those of you who have been following along is show you how to actually tear down this cluster now that we have created it, so that we don't give Google a bunch of money that we're not getting any value out of. The last section here describes how to do that, turning off Jupyterhub and computational resources. This shows you how to do it with the command line. Another easy way to do this is if we move that down. If you click on the hamburger menu and go to Container Engine, click this thing, it should show you the cluster that you've created here. And so you can go in there, click check mark, and just click delete, and that should work for you. It's just going to delete the whole Kubernetes cluster. Yeah.
Can you like download what you've done to your computer so that if you want to spin it up, you can just do it immediately?
Yeah, so this is I think this is like a big ongoing question that we're trying to figure out a good way to handle. Like a few people at this workshop have asked that question of just what do you do when you want to move off of that Jupyterhub? Whether that means like being able to grab the Docker image, or whether it means like being able to just download all of those files as a zip, in an extreme case or whatever. I'm still not sure what's like the right way to do that right now. But it's something that we're trying to figure out, both from like, a technical perspective, just in terms of what tools are available. But all of these things are so new that there's also kind of like a growing like community of practice around this too, just trying to figure out what is the best way to use these things in a teaching setting or in like a data analysis setting. Which is a long-winded way of like not answering your question, but yeah.
If I understand it correctly, then you could encapsulate basically most of your environment in the Docker image, and then like the setup would be basically,
Yeah.
all you would have to do is just feed it that Docker image.
Yeah, depending on the computational resources you had set up around around what the cloud instance or that were on your computer or whatever. Yeah. But like the changes that users make to their notebooks, if they wrote a bunch of stuff, it's still kind of, we haven't got a good model for how they could get that onto their own machines or whatever. So this is one way that you can do it. The last way that you can tear down the cluster is, actually, I want to stress something really quickly if I can find it. There's another thing over here called Compute Engine. If Google's JavaScript is not going to mess up on me, which which it definitely is. All right, way to go, Google. Let me refresh this page. I only want to show this to you because this has burned me before. If you go to Compute Engine, which seems like it's the reasonable thing to click on, since you want to see what sort of computational things are running on your deal, we'll see a list of all of the pods here, right? So you might think to yourself, okay, if I want to tear this down, I just highlight each of these things and click delete. And it will delete them, but the problem is that Kubernetes is still running in the background, and Kubernetes' reason for existing is to make sure that those computational resources are always there. So we may think that we're deleting this if we do so, but what we're actually doing is just creating a problem that Kubernetes then solves by recreating all of those pods. So we're not actually deleting anything. You need to make sure that you delete the container engine itself, not the individual nodes. Alternatively, you can run the command that we have right here. Okay, so I think that we're probably going to break for lunch, unless you want to, I can stick around and chat and answer questions and stuff like that. But
this conversation
yeah.
for lunch. I just want to make sure that we have enough time to go get lunch and be back to take a group photo downstairs right out here at 1 p.m. So be down here, right outside. When you go down the elevators and exit the building, and the doors that are closest will be in the courtyard down here. We'll take a group photo at 1. And so let's break it now and
Okay.
go to lunch and
Cool.
grab Chris if you want to talk more.
All right, cool. So thanks.